In this video, we'll talk about how to find the absolute maximum and minimum values for a function using calculus. First, let's look at two definitions. Suppose we have a function f. It's defined on the domain I. Then an absolute minimum is basically the y value of the lowest point on the graph. And the absolute maximum is the y value of the highest point on the graph. Now introducing a theorem called the extreme value theorem. It says a continuous function f defined over a closed interval a, b must have an absolute maximum value and an absolute minimum value over the interval a, b. Basically, a continuous function f defined on a closed interval must have a highest point and a lowest point in the graph. Now we will go over the steps of how to find the maximum and absolute minimum values using this example. Step 1 is find the derivative of f. So f prime of x here equals 3x squared minus 3. The second step is find the critical values. We know critical values happens when the first derivative of f equals 0 or does not exist. For the given function, f is defined for all real number x, so we don't have the case of f prime, it does not exist. So we will look at the case of when f prime of x equals 0. So make 3x squared minus 3 equals 0, and we solve that. We will have two solutions. One is positive 1, one is negative 1. Step 3 will list all the critical values and the and points of the given interval. We will put it in an increasing order so that it's easier for us to see. So starting from negative 2, right, and then we have negative 1, next one is 1, and the other endpoint, the highest endpoint is 3 over 2. Step 4, we want to find all the corresponding y values for all the values in step 3. Which means we want to find f of negative 2, we want to find f of negative 1, we want to find f of 1, and we want to find f of 3 over 2. What are those values? So if you find them, okay, so those are the 4 y values, and among all these values, the greatest value will be the absolute maximum for this function. So 4 will be the absolute maximum. And the smallest value among these 4 values will be the absolute minimum for this function. So we have 2 zeros. Basically, 0 is the absolute minimum. Now let's look at another example. Find the absolute maximum and the absolute minimum values of the function f of x equals 2 times e to the 3x over the interval negative 2 to 1/2. So we'll follow the steps we talked about earlier. Step 1 is to find the first derivative of f of x, which is, in this case, is 2 times 3 times e to the 3x, right? It's 6 e to the 3x. Step 2, find the critical values. So we will make f prime of x equals 0. First of all, there's no does not exist case, so we won't look at that. X is defined everywhere, for all real value of x. So when will f prime of x equal to 0? Well, it turned out this function is never equal to 0, right? 6e to the 3x is always positive and is never equal to 0. What does it mean? That means this function has no critical values and also, since the first derivative is positive all the time, it is an increasing function. So if a function is an increasing function over an interval from -2, let's say it's here, to 1/2, let's say it's here, and the graph is kind of like that, excuse me, kind of like that. So basically, in this case, f of -2 will give you the absolute minimum, and f of 1/2, basically over here, will give you the absolute maximum, because we know our function is an increasing function. So the leftmost point will be the minimum value and the rightmost point will be the maximum value. All right, so let's do the calculation. F of -2, plugging into function f, that will be 2 times e to the -6. What is that, right? If you put it in a calculator, that will be around 0.05. So let's say, so here will be -2. It's not exactly 0.05, but it's around 0.05 here. And this point, the highest point happens at when x equals 1/2, right? Plugging 1/2 for function f. You will have 2 times e to the 3/2. You can put that into a calculator. You will get around 8.963 if you round to 3 decimal places. Now let's look at another theorem. Suppose f is a function such that the f prime of x exists for every x in an interval I. So basically this means f is differentiable at every point in that interval I. And there is exactly one critical value, c, in I, such that the first derivative of f of c equals 0, then this means we have only one turning point, right? Either we have this case or we have this case, right? So this f of c is either your absolute minimum or your absolute maximum. So how do we decide if the second derivative of f of c is positive, then you have an absolute minimum, and if the second derivative of f of c is less than 0, then you have an absolute maximum at f of c. Now let's look at this example. Find the absolute maximum and minimum values for this function g of x. Okay, we know first we need to find the derivative of this function. So g prime of x equals, if you go through the calculation, you get 2 minus 18 over x squared. So now we want to find the critical values. Okay, so basically we want to know when g of x is equal to 0 or does not exist. Well, don't forget, it's over the interval from 0 to infinity, right? Okay, so make g of x equal to 0. We have 2 minus 18 x squared equals 0. Solving the equation, you will get x equals plus or minus 3. Now, for this g prime of x, actually, x cannot be equal to 0, right? So where is it undefined? Basically at x equal to 0. So these three values are the critical values for the function g of x over all real numbers, basically from negative infinity to infinity. But we want to know what happens in the interval from 0 to infinity. Well, in that case, we only have one critical value in that interval, which is x equals 3, right? Because negative 3 and 0 are not in this interval. Right, so only one critical value here. We just learned that if a function is differentiable over we just learned that if a function is differentiable over the given interval, which r is, and has only one critical value, in our case, we have only one critical value, which is 3, then, in our case, f of 3 is either the absolute maximum or the absolute minimum, right? So we want to decide if f of 3 is absolute maximum or absolute minimum. How do we decide that? Excuse me, g of 3, not f of 3. G of 3 is absolute maximum or absolute minimum. We want to know the second derivative of g of 3 is positive or negative, right? So that will tell us if we have this value as absolute maximum or absolute minimum. So here I want to find the second derivative of g of x. We have the first derivative of g of x here, so that is 36 over x cubed. We plug in 3 here for this function, for g, second derivative of g. It's 36 over 3 cubed. Oh, I won't do the calculation, but I know it's positive. So that means, you know, we have, it's concave up, right, at g of 3. So basically we have an absolute minimum at g of 3. What is this absolute minimum value? You will find g of 3. That is 2 times 3 squared plus 18 over 3, which is 12. All right, so we have a minimum value, absolute minimum value at the point 312. And if we graph a quick sketch for this function g of x, it has an absolute minimum at g of 3, right? And then after g of 3, it's increasing all the time, right? So there will be no absolute maximum, but there's one absolute minimum.